Hello, everyone, and thank you for joining us today. With the US elections at the forefront of everyone's mind, the data science behind election predictions is something that we should all be thinking about. So, thank you for joining today's discussion, where we will be focusing on how data science can be used to predict elections. This event is part of the Think series co hosted by the Advocata Institute and Echelon magazine. This will also be live streamed on the pages of our streaming partners, Echelon magazine, Economy Next, Blue Chip Training and Consulting, News Hub LK English, Business News, Citizen.lk, Economy and Business Sri Lanka, Daily FT, The Morning, the Sunday Morning Business, the Night Watchman Society, Code 2.0, and Punchitti. Before I introduce our speaker for today, I'd like to run through some very quick housekeeping. During the lecture, we'll be keeping mics and cameras switched off to avoid distractions. If you have any questions or points of clarification during the session, please feel free to send them in through the Q&A option. You will find an icon at the bottom of your screen, and you can send your questions in through that. After the lecture, we will open the floor for questions. I would now like to introduce today's speaker, Mr. Nuwan Seneratna. He is a software engineer and computer scientist specializing in artificial intelligence. He's the founder of ColomboLabs.inc and was the former engineering manager at Facebook from 2009 to 2017, and has an MSc in computer science and AI from the Stanford University School of Engineering. Nuwan, it is a pleasure to have you at today's event. And without further ado, I'd like to hand the floor over to you.
Thanks, Aneetha, for that very kind introduction. Thanks, Advocata and Echelon, for this opportunity to participate in this discussion. And last but not least, thanks everyone joining over Zoom and Facebook Live and possibly elsewhere. Okay, so this talk is both about predicting elections and about data science. So the plan is that we'll discuss three sort of mini case studies related to elections, and I'll use those as an opportunity to also introduce some kind of basic data science concepts. The first case study is about fact-checking election predictions. Now we can't really do election predictions if we can't tell the difference between a good prediction and a bad prediction. So we will see how we can fact-check predictions. The second case will be about using survey data to predict elections. And the last case will be about using real-time data, that is data of currently released election results to try and predict the end result. Okay, let's get started with the first case. Let's assume that you have a friend who claims to have this superpower of being able to predict elections. Let's say he says that, okay, I know the winner of the next presidential election. And let's say you're skeptical and you ask, can you prove it? And then your friend says, I have predicted the winner of 2 past elections. Okay, so what do you do with this information? Do you believe your friend? Do you not believe your friend? Okay, what do you do? This is where data science comes in. So what exactly is data science? So data science can be defined as using scientific methods on computer data to get useful information. And some usually increasingly, we refer to large amounts of data. The keywords for me is data, scientific methods, and useful information. Basically, you apply scientific methods to data to get useful information. So for example, you have a voter survey, say, and you can apply survey statistics to get useful information like what is the proportion of votes a certain party is going to get. That's going to be our second case. Our third case also falls into the same pattern. We are going to use current results of elections released so far in order to train a real-time model, and using that model, we can try to predict useful information like what's the final result of the election. And we can use this same pattern to verify your friend's claim. We can try and see whether we can trust him with predicting the next election. Okay, so how do we do this? Let's say we are skeptical. What if your friend is actually not a genius, but a monkey who randomly calls elections, completely randomly? And so if that monkey is to predict 2 elections, there is a 1 in 4 chance that the monkey just got lucky and came up with the two right answers. Okay, so statisticians call this monkey hypothesis a null hypothesis. And they also call the hypothesis that we are trying to prove in this case, hey, your friend is a genius, the alternative hypothesis. And to choose between these two hypotheses, we do some kind of experiment or a test. And so statisticians basically call it the test. And you pass the test, you accept the alternative hypothesis. You fail the test, you accept the null hypothesis. So related to these terms is this term statistical confidence. So statistical confidence is probably the most important concept in statistics. It is the probability of failing the test given that the null hypothesis is actually true. Okay, so what this actually means is in the case of our example, it's the probability that this prediction test is failed given that your friend is actually a monkey who picks results at randoms. So in this case, there are three scenarios in which the test will be failed. And so the statistical confidence of this test is 3 above 4, which is 75%. A very similar term to statistical confidence is statistical significance, which is sort of the complement of confidence. It is the probability of passing the test given that the null hypothesis is true. So in this case, it is the case where the monkey by chance happens to get the two answers correct. And so if you notice, significance is 1 minus confidence or 100% minus confidence. So as you can sort of intuitively understand, the most important thing that you need to know about confidence and significance is that high confidence is good, but high significance is bad. Okay, so in our test, where your friend claimed to be a genius by predicting 2 elections, the significance we saw was 25% and the confidence is 75%. Now, this 25% and 75%, is it too high? Is it too low? How do we choose? So statisticians usually tend to pick these limits somewhat arbitrarily. So for example, significance could be 1% could be considered a limit, 20% could be considered a limit. It depends on the case, but 25 on the whole seems to be too high. So basically a test with just these 2 predictions is not sufficiently significant. So what we need to do there is we need to increase the number of tests that, the number of elections that your friend tries to predict. So for example, if your friend can correctly predict 4 elections as opposed to just 3, then the significance drops to 1 upon 16, which is about 1.2%, and confidence is now over 90%. So if you pick an arbitrary line of a 10% significance or 90% confidence, then a 4 election test would work. If you're even more strict and you want 1% significant, which is 99% confidence, then you'll have to go with about 7 predictions. Okay, so in our current example, so what is our conclusion? Is your friend a random predicting monkey or is your friend a genius? The correct answer is that it's actually neither. In this case, what we do is we actually reject the test. So our test has a significance of only 25% or a confidence of 75%. The significance is too high, or equivalently, the confidence is too low. So what we should do in this case is to actually define a different test. If your friend says like, hey, I predicted 2 elections, therefore I can predict the next, you need to go back and say, hey, no, you need to predict more than 2, maybe 4, or even more than that. So the most basic fact-checking question you can ask with the election prediction, but almost any other statistic is like, what is the statistical confidence of that statistical claim that you're making? If there is no good answer to that question, then it probably is a bit of a dubious conclusion. Okay, so that's our first case. Okay, so let's move to our second case. The second case is about predicting elections using surveys. So at the moment, there's a lot of excitement about the outcome of the US elections. People who are following the sort of the evolution of the campaign before election day, might have seen kind of many different predictions by different organizations. This is a particularly kind of a visually interesting prediction by 538. So how do people like 538 make these predictions? So all these predictions are based on polls. Various organizations do surveys to see, okay, how people might vote. So this is an example of, this is actually one of the last polls carried out before the US presidential election by an organization called Morning Consult. We'll come back to this later. But first, let's do a thought experiment to understand how polling and particularly sampling work. So here's an example. Assume there are 4 groups of people. Each group has 3 voters. And the first group has 3 SJB voters. The second group has 2 SJB voters and 1 SLPP voter. The third group has 2 SLPP and 1 SJP. And then the third group has all 3 SLPP supporters. Okay, so you have these 4 groups, all have a sort of a different composition. Now imagine you don't know which group is which, but you randomly pick one of these groups. So you now randomly picked a group, it has 3 people, but you don't know who those 3 people are. Next, what you do is you randomly pick, out of those 3 people who you don't know who they are, you pick 2 people randomly. And then you find that those 2 people are, one is a SJP supporter, the other one is an SLPP supporter. Okay, so why did I pick this example? If you think about it, this is exactly how sampling happens. So the actual population out of which you take a sample, let's say you're trying to take a sample from the Colombo district voter population, you don't really know exactly what that actual population looks like and how they're going to vote. So the actual population is sort of a black box. But you know that in theory, that actual population could take all sorts of different compositions. So when you take a sample out of it, you get some visibility into what the actual population looks like. So for example, since in our sample there's 1 SJP supporter and 1 SLPP supporter, we know that the first group where all the people are SJP supporters and the last group are impossible because the first one has no SLPP supporters while the last one has no SJP supporters. So we know it has to be one of the 2 middle groups. And through symmetrically, we might assume that, okay, there is an equal chance that it could be either of those groups. So something somewhat obvious about samples is it tells us something useful about the population. But the other thing about samples is that samples are not exactly like the population. So for example, in this sample, the proportion of SLPP voters is 1 out of 2, which is 50%. But none of the actual populations have this ratio. So we have one population with 33% SLPP and another population with 67, but no population has 50%. So the point here is the characteristics of the sample need not match the characteristics of the population exactly. And statisticians call this sampling error. So when you take a sample, it won't be exactly like the population. And so we need to keep this in mind when we make various conclusions about the population using the sample as an estimate. So for example, the sample mean is not equal to the population mean. So another similar place is like in our particular example, if we want to estimate the SLPP voter percentage based on our sample, and we can't say that the SLPP voter percentage is 50% or because our sample has 50%. Using the sample, we get a sense of the distribution of what the actual population looks like. And in this case, we can only say that it's either 33 or 67. We don't say that it's 50. So we can also represent this in a chart. So in this chart on the x-axis, you see the various possible SLPP voter populations, and you also see the populations below. And on the y-axis, you see the probability of these populations being the actual population, given that we have observed a sample of a certain type. So as you can see, the first and the last are impossible, and there's an equal 50-50 chance of the 2 populations in the middle. So what I picked here is a toy example with where our population has only 3 people and our sample has 2 people. But these conclusions apply to a real population. So for example, if we take a real population like the population of Colombo as our population, and we take a sample out of it, and let's say we take a sample of 100, and it turned out that our sample had 40 SJP supporters and 60 SLPP supporters, the SLPP vote percentage in the population, we can't conclude that it's 60%. We can only conclude that it'll follow some sort of a distribution. It'll be around 60%, and it usually takes a sort of a bell shape like this, around 60%, but it's not exactly 60%. Next, suppose we do this. Let's draw 2 lines either side of that sort of bell shape, such that the area in the middle bit under the curve is about 90% of the total area under the curve, right? Or alternatively, the area under the curve to the left of the left line and to the right of the right line in total is 10%. So if we draw those lines so that the middle bit is 90%, and let's assume that the lines cross at 52% and 68%, what can we conclude? We can conclude that there is a 90% probability that the SLPP vote percentage in the population is between 52 and 68, right? Or alternatively, we can say it's 60 plus or minus 8. So this is typically how we turn an observation in a sample into a conclusion about the population. Now you might say that this range is too big. 52 to 28 to 68 is 16 percentage points. That's a very vague kind of estimate. Can we get better? The answer is we can, and what we do is we just get a bigger sample. So if we get a sample of say 1,000. And we might end up with a result like this, say there are 450 SJP supporters and 550 SLPP supporters. Note that in the same population, if you take 2 samples, you might not get the same mean. There's no reason why you should get the same mean. But anyway, as before, we get a sort of a bell curve, but the bell is a lot sharper. It's almost like a point now. And the error bounds are much narrower. So earlier we got, what was it, 52 to 68, but now we got 52.5 to 57.5, and plus or minus 2.5 instead of plus or minus 8, I think it was. So this is a general characteristic of any estimate that you get from a sample. What you would report is actually a range and a probability associated with it, not a fixed number. You would never say that the SLPP voter percentage in the population is 55%. We will say it's a range. And so these, as we saw earlier, these are known as error bounds. So this is the second fact-checking question that you could ask. What are the error bounds? If someone reports a prediction saying, hey, I think the SLPP are going to get this percentage of votes, but they don't report error bounds, it's probably not based on statistics. It might be a guess or something like that. Okay, and all error bounds are associated with some confidence. You could ask 90%, but it doesn't have to be 90%. It could be 90%, 95%, or as long as the confidence is kind of reasonably high. Okay, so let's look at one of those early examples that we saw. This is a poll by Morning Consult just before the US presidential election yesterday. And in the first row, you see the a prediction about the state of Arizona. And you will see this MOE, 3%. MOE stands for margin of error. And so what this means is this, according to this poll, Joe Biden leads Donald Trump by 2 percentage points, but the margin of error is 3%. So what that actually means is it's actually 2 plus or minus 3. So it's actually 2 minus 3 to 2 plus 3. So it's minus 1, which is actually Biden is behind Trump, 2 plus 5, which is Biden is ahead of Trump by 5 points. So I mentioned earlier, this MOE is always associated with a percentage confidence. In this case, it's 90%. And you'd also notice they've reported the size of the sample for each of the polls. So if you take the state of Florida, the poll has almost 4,500 people. And you can see the states with bigger polls, the MOE is smaller. So in Florida, the MOE is only 2%, while in Colorado, which has a much smaller poll, the MOE is 4%. So here's another interesting example. This is by The Economist, and here they're estimating the total electoral college votes they expect each candidate to get, and they have kind of plotted it across time. And you see that before around when COVID was kind of picking up, it was very close, and since then the prediction has got wider. But one thing to keep in mind here is that the error bars are actually quite wide. So while it might seem that Biden is ahead, what you see as the light blue shading is the 95% confidence bounds for Biden, and they actually overlap with Trump's 95% confidence bounds, which means that there is a chance that Biden will actually get more electoral college votes than Biden, according to this prediction. Let's look at another prediction. So this was a prediction made related to the recently concluded parliamentary election in Sri Lanka, and it was trying to predict the number of seats different parties would get in the Colombo electoral district. The sample size was 1,000, and the results were reported at a 90% confidence level. So everything sort of looks good on the surface. We have error bounds and so on. But if you remember the final results of the election, we see that this poll has got the top two party results kind of almost mixed up. So one theory that might explain this is they actually got the two parties mixed up. But that's not what happened. What happened was something almost as embarrassing. So while this poll was supposed to be for the whole Colombo district, the sample data that they collected was collected only from the Colombo municipal area, and so that's the top left area that you can see, which in terms of voting patterns is very different from the Colombo district as a whole. So what actually happened was when they should have taken a random sample, the sample wasn't really random. So this is a third way in which you can fact check election predictions. You could ask the analyst whether they actually checked whether the sample was random. And it's not enough to think that your sample is random. You need to do some sanity checks to prove that your sample is random. And so what are some examples of sanity checks? So in a survey where you might ask the people, okay, who are you going to vote for? In addition to asking that question, you should ask some additional questions like, what's your age, gender, ethnicity, things like that, some basic demographic information, so that you can compare it to the demographics of the population that you're trying to measure as a whole. So for example, if you have a sample and 90% of that sample are males, then that can't be right because 90% of the Colombo district are not males. Similarly, if the sample has 80% of the sample are people aged, say 20 to 40, that doesn't sound right either because it doesn't match the population. Another sanity check which would have caught this particular problem was ethnicity. If you take the Colombo Municipal Council, in terms of ethnicity, it's quite diverse. But if you take the Colombo district as a whole, that diversity kind of becomes a lot more homogeneous. And so definitely if this question was asked, we could have sanity checked the difference between the Colombo Municipal Council and the Colombo Electoral District. And another common practice is to get data from kind of various sources. And so one sort of interesting source for data are various social media platforms like Facebook, Twitter, and so on. These are very powerful data sources because you can get data very efficiently. You can collect the data very easily as opposed to, say, phoning someone over a poll or like even doing polls in person. So they are very efficient at collecting data. But one problem is that the people who tend to use this platform tend to be, again, not representative of the population. So if you take a platform like Facebook, it tends to skew towards a kind of a younger demographic, and in countries like Sri Lanka and India, it tends to also skew male. So in situations like this, there are various statistical techniques that you can use to correct for this problem, but in general, you need to be kind of very careful about it. It can introduce all kinds of unexpected errors. Okay, so probably the most important, the most famous example is of pollsters getting it wrong was probably the previous US election, where many of the pollsters said that Mrs. Clinton was going to win, and instead Mr. Trump won. And after the election, there was a lot of soul searching done around, okay, what went wrong here? So I want to raise 2 points. One is that one of the reasons for the difference between the polls and the actual results was many Trump supporters were not comfortable with sharing that they were Trump supporters. So you had these silent Trump supporters who were not getting recorded in the polls. But to be fair, by the pollsters, if you take this poll, what it's actually saying is there is a 28.6% chance that Trump would win. So that's actually higher than 1 in 4. It's higher than tossing a coin twice and getting 2 heads. So I think psychologically, many people sort of subconsciously interpreted this result as no, Mrs. Clinton is going to get 71.4% of the vote, which is very different from a 71.4% chance of winning the election. So I think to a certain extent, people also misinterpreted what this actually meant. So one last thing about these polls and statistics is that you could ask a person who they're going to vote for. They could actually honestly reply exactly who they think they're going to vote for, but then on election day they could go and they could change their mind. So statistics makes this assumption that the future is like the past, and all its conclusions are based on this assumption. So it's important to note that this might not be the case. So that's our second case. And let's take a pause here and see whether we've sorted out our Q&A issues.
Yes, thank you, Nuwan, for those 2 very interesting case studies. Q&A issues have been sorted out, and we've got a bunch of questions in as well. So if I could just kind of collate a couple of the questions, because some asking fairly similar questions. One question that has come through is, how is data collected and how accurate is it? And don't you need very large amounts of data to do that data science properly? Would you like to tackle that one, Nuwan?
Yeah. So let me answer this question specifically with respect to elections, and then we might actually generalize it. So on the question of how much data, I think this slide, which has the Morning Consult poll, gives you some indication. So how much data you need to collect depends on how accurate you want the poll to be. So for example, if you take a state like Colorado, one of the reasons why the poll was quite small is that Biden was ahead by a large amount, so that you're fine if the margin of error is kind of quite high, so that you can afford a kind of a lower sample size. On the other hand, if you take a state like Florida, where the election was much closer, you want to get a lot more precise. So the answer also depends on how precise you want to be. If the current data it doesn't give you a precise enough answer, then you might need to increase it. But the opposite might also be true. You might have too much data than you need to answer the question that you want to answer. So it depends on the question you want to answer. So in general, there is this sort of diminishing returns that you see with kind of larger and larger samples. So what I mean by that is, let's say you have a sample of 1,000 and you have a sample of 2,000, and then you say you have a sample of 3,000. So the difference between the 1,000 and the 2,000 is probably more than the difference between the 2,000 and the 3,000, or even the 2,000 and the 4,000. So usually there is some limit at which beyond that it's diminishing returns. Okay, you're going to get a slight improvement by improving the sample, but not much. So it's actually important to try and minimize the sample size by understanding what is it that you want to do.
Sure. Thank you, Nuwan. If I could pose one more question to you. This is also two questions that have come in asking how did the sampling in the case of the United States go so wrong with reference to Florida, for an example. And given that in the 2017 election, the polls didn't predict the actual result, can people really trust polls?
Okay, so a couple of things to clarify. So this is one of the 2016 polls, probably one of the more reputable 2016 polls. So it's not that the poll said, so you don't interpret this as the poll definitely said that Mrs. Clinton is going to win. What the poll said was that Mrs. Clinton had a 71.4% chance of winning. So definitely higher than Trump, but the Trump victory wasn't impossible. So in general, this is an important thing to kind of keep in mind about statistics. Statistics doesn't give you certainty. It basically tries to make the best of uncertainty and kind of minimize uncertainty, but it can't completely get rid of it. So for example, statistics can't tell you, okay, if you toss a coin twice, what the outcomes are going to be. That you can't solve that problem using statistics, and this is something similar. So basically, another way of describing this result was you toss a coin twice. If you get heads twice, it's Trump. Any other result, it's Clinton. Actually, Trump's odds are like a little bit better than that, but roughly that's what this means. So you can't get absolute certainty.
Sure, thank you. Do you have the time to take one more question, Nuwan, or shall we leave that for?
Yeah, let's do one more question.
One more, sure. So we have a question coming in from Nival Columbage asking, how would you sample for a water survey, say for example in the Colombo district? Would it suffice to do a stratified random sampling based on relative populations in each electoral district? Or do you have to factor in other stuff like ethnicity and religion?
So I think the correct answer is all of those. So Colombo has, I think, around something like 15 electoral districts, and so if you and just as a sample which has 90% males, a sample which has a representation from only a handful of electoral districts is not going to work. So you should initially try to make sure that the sample is random enough so that you have representation across electoral districts. So assuming, say, if samples are done face-to-face or by phone, you could try and make sure that you're getting enough coverage in each of the electoral districts, because say assuming that you know where the sample people live. So you could try and make it as random as possible that way. But so what the question, the questioner mentioned, stratifying. Stratifying is what you do when you have these samples which are kind of not completely random. You try to correct for the differences across different groups by weighting samples in kind of different ways. So for example, if you have a sample which is, say, 60% male, 40% female, you can try and correct for that by weighting, by sort of overweighting or oversampling the female group to kind of correct for that mistake.
Sure. Thank you, Nuwan. Shall we pause on the questions for now? I'll let you move on to your final case study, and then we will have a little bit of time at the end of the discussion, at the end of the lecture, to take a few more questions.
Okay, sounds good. So let's move on to our last case study. Okay, so in our second case study, if your sample is big enough and it's also properly it's randomly collected, it's fairly straightforward. You're likely to get a correct answer, correct conclusions with fairly basic statistics. So I want to discuss a case where we can use some more powerful data science techniques and that's this predicting elections in real time. So what I mean by this is when new results in an election come in, you try to use those results to try and predict the final result. So for example, in the current US election, various results are coming in and people are trying to predict, like, will Biden win this state, or will Trump win this state, and so on. And so how you do it is you train a model using historical data, and you send your new results through that model, and that will predict what the final result would be. So in this case, I'm not going to discuss the US election. I'm going to discuss the recent general election in Sri Lanka, where we can use a real-time model to predict how many seats each party is going to get at the end. So before we move on to the model itself, a couple of quick thoughts on data collection and mining. Especially in areas like machine learning, the quality of the machine learning depends on the quality of the data. And unfortunately, many students of machine learning are not willing to put in the hard work beforehand to make sure that data collection and data mining happens in an efficient way. So this is not very exciting. It can be tedious and a lot of hard work, but it's still very important. So in our case, there are two sources of data. The first source of data are the historical election results. And all Sri Lankan election results are published on the Election Commission site, where you can extract it. One problem is that these results are published as PDFs. So while they're in a digital form, they're not in a form that can be easily analyzed. So one pre-analysis step is to actually pass these PDFs and convert it into a CSV or a JSON file that can be more easily passed. So that is one of the first steps in this. If you want to build a real-time model for Sri Lankan elections, you don't actually have to do this step, because I've already parsed and cleaned up the data, and you can find that on my GitHub page. Okay, the second source of data that we need for this real-time prediction is the actual results as they come in. This is much easier to collect because since the last couple of elections, the Election Commission have been publishing these real-time results on the official results website as they come in. So all you need to do is to just go to the site and download the results. Or you can write a script which downloads those results automatically. Okay, so that's the data. Let's now see how we can build a model, and we're going to build a machine learning model for this. But let me give a little bit of introduction to machine learning before we go into the model itself. So here's some data about house prices. On the x-axis, you have the square footage of the house, and on the y-axis, you have the price of the house. So basically, what this kind of indicates is that there's a linear relationship between the area of the house and the price of the house. By the way, these are this is US data, so the price is in dollars. So if you apply a little O-level geometry to this, you'll see that, okay, that line is y equals mx plus c. Or in other words, the house price is a constant times the house area plus another constant. More generally, what's happening here is we are defining house price as a function of house area. So therefore, if you know house area, you know house price. So a machine learning model, a model output by machine learning training, is actually a fancy word for just a function. A machine learning model is actually a function which maps what you know into what you want to know. So if you have that function and you know something, you can map it into what you want to know. Or in other words, it's a function which maps data into useful information. So none of these functions are perfect, because as you can see, that line doesn't fit all the data points. There are some dots on that chart which are kind of away from the line. And so this is the error. So all machine learning models also have associated error. So how does this work in practice? So what you do is you write some code which takes in the x and y variables, and you can write a function which in turn takes the x and y variables and outputs the parameters of the model. In the case of the simple linear model, it's the m and the c in the y equals mx plus c. Now, many introductory machine learning courses will start with linear regression, because linear regression is probably the simplest kind of machine learning algorithm. But surprisingly, it works in many cases. So for this real-time prediction, I used a variation on linear regression, but even basic linear regression would work quite well. And in our example, the X and Y's, the Y's are what you want to know. So for example, you can build a model to find out how many seats the SLPP are going to get in the Colombo district. And the X are the results that you feed into this model. So many people ask, okay, why did I use linear regression in this case? Why can't you use a more sophisticated model? Let's say using deep learning. So the answer is that you can. And if you use a more sophisticated model, you could get a slight improvement, but not much. And the reason for that is more sophisticated models like very complex neural networks give a kind of incremental benefit only when you're working on kind of very large sets of data. So a single Sri Lankan election would have a few kilobytes, actually maybe about 30 or 40 kilobytes of data. So our entire history of elections plus various other data points you might want to use, like demographics and so on, all the data will be less than a megabyte. And so linear regression would work perfectly fine. Okay, let's see the model of our output. So you probably remember this visualization from 538. So here's where 538 predicted a 10% chance of a Trump win and a 89% chance of a Biden win. Each of these circles represent a possible scenario, a possible future outcome of the election. So for example, this dot represents this outcome. So this is exactly how our model works as well, and the output is very similar. So for example, for the model which predicts the SLPP seats in the Colombo district, it doesn't output one value. It does simulations and produces a set of different values, which are all kind of equally possible in the future. So here's an example of 20 simulation outputs. And so what we do here is we sort the 20 and we pick the 18 in the middle. And if you think about it, 18 out of 20 is 90%. And this gives us a 90% confidence of the number of seats in the SLPP are going to get in Colombo. So basically what it's saying is, okay, there's a 90% chance that it's going to get between 11 and 13 seats, or alternatively 12 plus or minus 1. So in my model, I actually use 95%. In that case, instead of 20, you do 40 and pick the 38 in the middle. So 38 out of 40 is 98%. Okay, so let's see how you visualize this. So visualization and data presentation is sometimes considered less science and more an art, and sometimes gets not enough attention as it should. I'm not expert in the area, but I'm going to describe how I attempted to visualize the results of the real-time models that I built. The complete result looks something like this, and I'd like to go through some of the principles that I used when I designed this. So the most important principle in designing visualization is probably minimalism, in that you don't want to put too much information which is not necessary. So for example, on the left-hand side, you see the results of every single party being reported. And actually, most people probably just want to know what the top 3 or the top 4 are. Another example is if you take the percentage vote, is it actually necessary to have the percentage vote to 2 decimal places? 22% sounds everything that you want. You don't need to know that it's sort of 22.48. So that's minimalism, trying to minimalize the design. Paradoxically, the other concept is maximalism. So what I mean by that is you have a limited space to show something, and so you should try to make the best of that space. So the map on the left has the winners of the recent general election. The map on the right has the same results, though for a subset, because not all the results have been released at that point, but it has more information in that it uses color shades to say how much votes the winning party got. So from the image on the right, you can say that the SLPP's performance in Nuwara, for example, was very different from Monaragala or say Polonnaruwa. So the last bit was the actual projection results as itself. You saw that the model said that the SLPP was going to get 11 to 13 seats in Colombo. And so what that means is the model thinks that the SLPP is going to get at least 11 seats. So this was represented as kind of 11 circles in the SLPP color. Similarly, there was another model which predicted the number for the SJP, and it predicted 6 to 8. And so you've got the 6 green circles, and then the remaining circles represent up for grab seats. And so you do the same thing for all the districts. And the final results look something like this. And so you have the colors for the different parties who have guaranteed seats, and then the remaining seats which are still in play are sort of empty circles. And so finally, the final result looks something like this. What you see on the left are the official finalized seats, and what you see on the right are the projections about 2/3 of the way into the elections. So basically, it was very clear from the projection what the final result was. If you think about it, this is very similar to what the final result actually was. Okay, so that's all I had. Before I kind of end, there are 2 people that I should thank. One is my sister Devini, who's actually a data scientist, unlike me, and my wife Kanchana, who gave a lot of good feedback on these slides and some suggestions as well. Also, if you want to learn more details about all the things that we discussed today, you can follow my articles on Medium, and you can also follow me on Twitter, which has kind of similar stuff. So good. So let's move on to Q&A.
Great. Thank you so much, Nuwan. So for the Q&A section, we have quite a few more questions that have come in on the Q&A chat box. But if you would also like to ask Nuwan your question directly, you have that option. Just raise your hand. So to raise your hand, there's just a little hand icon at the bottom of your screen. Click on that, and then I will be able to call on you, and you will be able to unmute your mic or turn your video on and ask the question directly. But while people decide whether they're going to make use of that option, we can start with some questions that have come in on the chat. So we have one question in from Shamindra Kulamanage asking, in exploring how to create interactive digital maps, I realized the need for GeoJSON files for admin districts and polling division level for elections. Is there an open database for that sort of information in Sri Lanka?
The correct answer is yes. The Department of Census and Statistics has an open data set. Unfortunately, it's not very clearly visible. So if the questioner can just send me some contact details, I could send more. Or actually, I might actually post it on this talk page, more details on that. I'll just make a note of that.
Great, thank you, Nuwan. I think we have one person raising their hand. Kure or Ms. Kure? Ms. Kure. I've asked you to unmute if you would like to ask your question.
I think the question is on mute still.
1 second, I'm asking. Yeah.
Hello.
Please, yes. Please keep your question brief.
Yeah.
Go ahead.
I'm Ns Kure calling from Japan. Thank you very much for interesting presentation. I'm just wondering whether you are engaged in some kind of macroeconometrics modeling for Sri Lanka.
Actually, no. I do this mostly as a hobby. My day job is in computer science, so I work in AI. This is more of a kind of a side interest. Maybe I should do what you recommend.
Oh, okay. I'm not recommending if you're doing. I'm also doing this kind of work. I'm the forecasting, so I thought maybe if you are doing, maybe I can share some of my work later on. Yeah.
Yeah, I would be happy to connect. Thanks.
Yeah. Thank you so much.
Thank you. So we have another question in the chat asking if there is a way to get our media to have more election coverage that's based on data science.
So that's a good question, and I think in general that probably applies to other areas as well, not just elections. I think at the moment, the responsibility is probably on the side of data scientists. I'm not a data scientist myself, but okay, let me wear that hat for a moment. I think we need to take more responsibility and on kind of demonstrating the value of data science outside our sort of inner circle a little bit more. So at the moment, it's seen as a sort of a very technical field. It's not the sort of thing where you might have a sort of a data scientist speaking on a popular TV show, as you might see, say, economist or a political scientist on a popular show. So I think data scientists need to get out a little bit more and promote the subject also a little bit more. So I think that's probably the first thing to do.
So I think this is something, the next question is something you have touched on briefly during the lecture. We have a question in asking, how do you increase the representativeness of a sample? For example, if you want to survey 1,000 people, how do you find 1,000 who constitute a representative sample? And then kind of tagging on to that, can there be a bias for people who would hide their answers because of social pressures? The example given is if your preference is not seen as to be woke enough.
Yeah, I think definitely in the case of the US election, that looks kind of very true. It was definitely true in 2016. It looks like it's true in 2020 as well. So I think that goes beyond elections. It might be sort of a cultural problem where you have a country where half the country are not willing to speak to the other half of the country, and so there's this real communication gap. And if you think about it, things like polls tend to be done by sort of intellectuals, statisticians, that sort of person, and there is a probability that those people are more concentrated on the political left, and so there's that unconscious bias going in as well. So that might be kind of another problem.
Should we have a few more questions? I think we can maybe take 2 more before we have to wrap up this session. So we have one question coming in asking, is there a software you recommend for use for real-time projections?
So all the projections, the only piece of software per se that I used was the Python programming language. Everything you need is actually there. From scraping the data of websites and passing the PDFs to actually training the models and also creating those visualizations. Those are also so for some. So I just use Python throughout because I'm quite familiar with that, and probably because I'm a computer scientist as well. Like coding comes naturally. But for some other pieces, there are other pieces of software which are better. So for example, for the last step, the visualization. Products like D3 using JavaScript are probably better than using Python. And then for things like scraping and mining data, there are, for example, customized products for extracting tables from PDFs, things like that. So you can use one for everything, but you can also do the opposite and use specialized software for each of the different things.
Great, thank you. So I'm going to pose 2 more questions at you, Nuwan. Sorry. We have another question that's asking, how do you get data using Facebook or Twitter?
So there are a couple of different ways. So one is if you can run polls of your own, and in which case you have access to all the data. You can especially if you're someone like an academic, you can go into a partnership with Facebook and Twitter, and so you might have access to anonymized data from inside, which normal people don't have access. I know Facebook recently just revamped their program by which they collaborate with academics, and so it has got a lot easier. So that's another way. And like a third way is, this is easier to do on Twitter than on Facebook, where you can just go and kind of scrape the data off the website itself, the same way you would scrape any website. But that can be tricky. Those platforms could block you, especially if it violates their terms. So yeah, there are a couple of different ways you can collect the data.
Sure. And the final question for today is, as someone who wants to get into data analytics, are there any courses you recommend?
So there are quite a lot of courses. So if you look at places like Coursera and Udemy, or just kind of look at YouTube, you have a whole lot of videos on the basics of data analytics. But I would recommend, before finding courses, find an interesting problem. Find an interesting data analytics problem that you're kind of really interested in, because the problem is you could take a course, but in 6 months' time, you could forget everything you learned unless you actually apply it. So I would say start with the problem and then see, okay, what are the tools and knowledge that you need to solve that problem.
Great. Thank you very much, Nuwan. So unfortunately, I think our time is up now. We have had about 70 people roughly sitting in on this Zoom call, with few variations as people join and leave. So I would like to thank you, Nuwan, for joining us today and for preparing all of this and for what was a very interesting lecture and discussion session. I would also like to thank everyone who has joined us today on Zoom and on our Facebook platforms. This event was a part of the Think series, which was co-hosted by the Advocata Institute and Echelon magazine. And on behalf of the co-hosts, I would like to thank our streaming partners, Echelon magazine, Economy Next, Blue Chip Training and Consulting, NewsHub.lk, NewsHub.lk English, Business News, Citizen.lk, Economy and Business Sri Lanka, Daily FT, the Sunday Morning Business, the Night Watchman Society, Code 2.0, and Punchiti. The Think series will continue, so please follow the Advocata Institute and Echelon magazine on our social media to stay updated. Thank you very much.
Thank you.